Okay, so I will wait for 2 minutes, and after that I will start power of lens. And this is the last topic of this chapter, and today we will finish this chapter. So Manha, tell me, what should be the next chapter? Human eye and the colorful world.
Yeah, sir.
Okay. Why? Because that chapter is related to the refraction of the light. Because in our eyes there is our eye works on the principle of the refraction. So I will start the human eye and the colorful bird after this. Okay. So 1 minute, for 1 minute I will wait. Hmm. Okay. So now I am starting. So power of lens. Power of lens means you have a lens, and power of a lens means a converging or diverging power. We will talk about. So to the extent the lens can converge or diverge the light rays is the measure of the power. Okay, is the measure of the power means the amount of convergence and divergence of a lens is simply is the measure of the power of the lens. Okay, so write the definition. uh, Power of a lens. Power of a lens is measure of measure of degree of convergence and divergence of of light rays falling on the lens. So power of a lens is a measure of degree of convergence and divergence of light rays falling on it. I have discussed that when the parallel rays are passing from the convex lens, so light rays after the refraction converges at a point called focus, and when the parallel light rays are just a minute, Shah Abdullah and Martin. Hello Abdullah. So I have started the power of a lens. Okay, so suppose you have a concave lens and light rays are coming from the infinite means from a very large distance. Light rays are coming. Suppose this is your concave lens. Light rays are coming like this. Parallel light rays are coming. So what will happen after the refraction? These light rays will diverge. These light rays will diverge. Okay. So the measure of degree of convergence and the divergence of a light rays falling on the lens is the power of the lens. And mathematically, there is one formula for the power of a lens. Power of a lens you can just define in another way. Power of a lens is defined as the reciprocal of its focal length in meters. So power of a lens is equal to 1 upon focal length of the lens, and you will put the focal length in meter always. Okay, so power of a lens, I will represent power with P. So power of a lens is given by 1 upon F, and this focal length F should be in meter. What is F? F is the focal length. Okay. What is the unit of a power of a lens? Unit of a power of length is a diopter. Yeah, good, Martin. Unit of power of a lens is diopter. Hmm. Now, with the help of this formula, uh, we will see what is one diopter. One diopter. One diopter. Very simple. You know that the power of a lens is given by 1 upon focal length, and this focal length should be in meter. So put the focal value of focal length as 1 meter. What you will get? P is equal to 1 by 1, means finally you will get 1 diopter. Hmm. 1 diopter you will get. So what is 1 diopter? 1 diopter is a power of a lens having a focal length of 1 meter. Hmm. Okay. So you can write 1 diopter is power of lens having focal length of 1 meter. Of means if a lens have a focal length of a 1 meter, then its power will be 1 diopter. Okay. So in exam, the definition can be asked, what is 1 diopter? Okay. Now, this small f is the focal length. Okay, remember, small f is the focal length. This small f for convex lens is positive or negative, Martin, for the convex lens?
No, it's positive.
Good. So it will be negative for the concave lens. For the concave lens, it will be negative. Now, simple question we have. So now we will solve the numerical. So a convex lens have has focal length of 10 centimeter. What is its power? All of you try this question by yourself. First write down the question. Okay, first write down all these things. Okay, First write down all these things, then write down the question and then solve the question. First write down this. What is power of a lens? Remember this point always. You will put focal length in meter. If in the question focal length is given in the centimeter, then you will convert that into meter. 1 meter is equal to 100 centimeter. Note down this.
I have done, sir.
Okay, good, very good.
Scroll down, please.
Okay. Okay, Martin completed.
Yes, sir.
Abdullah, Subhana, Manha, Hamna completed. Okay.
Yes, sir.
Write down this. So I am zooming it out. And write down this question and try to solve this question by yourself. Focal length is given. You have to calculate the power. You will apply this formula. Hello, Arshia. Why are you late today? So I have started the power of length. Okay, power of length. Power of length is the inverse of the focal length. P is equal to 1 by f. And we will put the value of f in meters. F means focal length. Martin, do you have OneNote in your laptop? Microsoft OneNote? And
No.
Manha, OneNote is there in your laptop? Microsoft OneNote.
Sorry, sir.
I'm writing here. ONE1 NOT note OneNote. So actually, I will share the notes of the entire chapter, and these notes will be open only on the OneNote. Like MS Word we have in the laptop,
Yes.
in the MS Word and Excel. Like this, there is an you can say app, the OneNote. So these notes will be opened on that OneNote. Suppose if you have missed any of my class, If you have came late, then you will your notes will be completed. You will get the complete content from my notes. Okay. So just write down this question and solve it. Very simple question, and tell me the answer. First of all, convex lens is given. Convex lens is given, na? So focal length of convex will be positive or negative? Positive.
Yeah, positive.
So focal length is given. So you will take focal length 10 plus 10 centimeter plus 10 centimeter because length is the convex length. Focal length for convex lens is positive. So now you will convert the centimeter 10 centimeter into meter. So how we will convert this? We will just divide this by 100. Okay, and this will be in meter. So you will get 1 upon 10 of meter. 1 upon 10 meter will be your focal length. Now what is the power? Power is given by 1 upon focal length in meter. So 1 upon focal length in meter. This is focal length 1 by 10. So what will be the answer? This 10 will be in the numerator. So your power will be plus 10 diopter. Diopter is represented by capital D. Got it? Martin, Hamna, Arshia, and all of you.
Yes, sir.
It's a very simple question. Now we will take one good question. After this,
Sir, I have done.
okay, good. So all of you completed, Martin and
Yeah, completed, sir.
Arshia, Hamna, Subhana, Abdullah. Okay, completed?
Yes,
Okay,
sir.
now I am moving. Just a minute. Hmm. Okay. See this question. This is from the NCRT. This question is from NCRT. So they are saying a convex lens forms a real and inverted image of a needle at a distance of 50 centimeter from the lens. Okay. So a convex lens is there. So that convex lens is forming an image at a distance of 50 centimeter. And the image is real and inverted. Image is real and inverted. If the image is of same size, see, same size, real, inverted, and same size, where is the needle placed in front of the lens? So needle here is the object or the image?
Object.
Needle is the object. So they are asking the object distance basically. And also they are saying find the power of the lens. Find the power of the lens. Okay. So first they are saying the image is real, image is inverted, and same size as object. Just wait a minute. See here. Have we discussed that? See, real image, inverted image, and real and inverted image, same size as object. See these 2 points. So when it will happen for this is happen for the case of convex lens. When you will place the object at 2f dash now. 2f dash means at a distance of twice of focal length from the optical center. This is the case. Real and inverted image same size as the object. So you can say that a convex lens will produce the image that is real inverted same size of the object when object will be placed at a distance of 2 times of focal length in front of the lens. So means suppose this is your convex lens, this is your principal axis, this is your principal axis, this is your principal axis, and this is the optical center, and your image is here, means at a distance of 50 centimeter. Okay, your image is at a distance of 50 centimeter. This is your image. Okay. This is given in the question. This information is given in real inverted same size of the object. This information is given. Now where you will place the object? Where you will place the object? So you will get the real inverted and same size as the object, the image. So you will place the object at a distance of 50 centimeter in front of the lens. Is it or not, Martin? Manha? So your object should be at a distance of, so you will say for writing answer, you will say the object should be at a distance of 50 centimeter in front of the lens, because image is here and this image is real and inverted and same size of the object, and this is true for the case when we place the object in front of the lens at a distance of 50 centimeter. Why 50 centimeter? Because the distance of the object and distance of the image and the distance of the object would be same. Object distance, this is image distance. Image distance. So this is your object. First is completed, means where is the needle is placed. So object here is needle. You will place the needle at a distance of 50 centimeters. Now next question. Power of the lens. Power of the lens. For the power there will be a requirement of the focal length. there will be a requirement of the focal length. So for calculating the focal length, I know this whole distance is 2f, or you can say this whole distance is also 2f. Okay, this distance is also 2f. So the value of 2f is given indirectly, that is 50 centimeter. So you can find from here the focal length, that will be 25 centimeter. Now convert this 25 centimeter into meter divided by 100. So you will get 1 by 4 meter focal length. And we know that the focal length of the convex is positive. So now apply the formula of the power. Power is given by 1 upon focal length in meter. 1 upon focal length. Focal length is 1 by 4. Finally, you will get plus 4 diopter. This is your final answer. This is your final answer. Write down. Here you have to apply your mind in this question. If you have any doubt regarding this question, any one of you can ask me. Diagram is not necessary. If you will not make the diagram for answer writing, then also you will get the full marks. But I make the diagram because I want you to understand things properly. From the diagram, each and everything is clear. So I will give you the advice that always try to make the diagram. When you will draw the diagram, your understanding level will be better. Otherwise, you know the power is equal to 1 upon focal length, and you will have the value. You will not understand, you will not anything, but you can solve the question, you will get the marks also. Completed this diagram, Martin, Hamna, Manha, Archia.
Yeah, I will check, sir.
Scroll down.
Done, sir.
Martin, should I scroll down?
Yeah, done, sir.
Okay, done. ठीक है, अब do this. Then we will discuss the power of combination of lengths. Okay, I think you all have written. Now write the heading, power of combination of lengths. Power of combination. So what is the meaning? Suppose this is one length, and just a minute. This is one length. I do not know which type of lens is this. This can be a concave or convex. And this is the another lens. Just consider this pen as a lens, both the pens. So two lenses are there. Suppose I have placed these two lenses very close to each other. So there will be the power of the combination of these two lenses. Okay. When you will combine the lenses, and finally you will get some power. That power is the power of the combination of two lenses. Suppose you have one lens like this. Which type of lens is this? Okay. So this is the concave lens, this is a convex lens. This is a concave lens, and these two lenses you have placed in the close contact. This is the combination of lens. You can have three lens also in the combination. You can have four lens, 5, 6, 7, 8, 9, 10. Okay. Combination of lenses. This is concave, we know. This is convex. For the concave, suppose the power is -6 diopter, and for convex the power is suppose +4 diopter, because we know that power is 1 upon focal length. Okay, and in meter, and focal length of concave will be negative. For the concave, the focal length will be negative, so power will be negative. So that is why I have taken negative power of the concave lens. So power of the combination. Suppose P is the power of the combination. So this P value is equal to power of the one lens plus power of the second lens. So the total power will be, suppose this is your first lens, this is your second lens. So plus 4 minus 6 means you will have a power of the combination, you will have minus 2 diopter. Minus 2 diopter you will have. So this is means in this way you will calculate the power of the combination of the lens. So you can write here, if a number of means 1 2 3 4 5 6 7 8 9 10, a number of lenses are placed in closed contact then power of combination of lenses is equal to the summation of the power, algebraic summation. What summation? Algebraic summation. Algebraic summation means you will add the power one by one according to the sign, negative sign and positive sign. Here we have just added the power with sign of the power. Here is positive sign, here is negative. Is equal to the algebraic sum V, algebraic sum of powers of individual lengths. Suppose if you have n number of lenses in close contact, and power of the combination will be P1 plus P2 plus P3, and you can just add it up. Okay, note down this, then we will solve a numerical on this, and this chapter will be okay. Write down this.
I have done, sir.
Subhana, Abdullah, completed. Martin,
Yeah, completed, sir.
Arshia,
Yes, sir.
and Hamna. Beta, if you don't want to speak in the class, then you have a chat box. You can write there. No problem. Okay. Okay, fine. Now we will solve one question, and this chapter will be finished. Very easy question. Two thin lenses of power plus 3.5 diopter and minus 2.5 diopter are placed in contact are placed in contact. Find power and focal length of the lens combination. So how you will solve it? Two thin lenses are placed in contact. One lens have this power, another lens have this power. So power of the combination suppose is given by P, and we have two lenses, so you will add both the power algebraically, means with sign you will add. So total power will be first power, that is plus 3.5. Here is plus sign. What is P2? Minus 2.5, or you can simply subtract this. Minus 2.5 minus 2.5. What will be the answer? Plus of 1 diopter. This will be the power of the combination. Now we have power and we want to calculate the focal length. We have power, we want to calculate the focal length. So we will apply this formula. Power is equal to 1 upon focal length in meter. We will get from here focal length is equal to 1 upon power. 1 upon power is 1 diopter. Power is plus 1 diopter. Plus 1. 1 by 1 is again 1. You will get plus 1 meter is your focal length. Okay, note down. Note down. So this chapter is finished from my side. Now what you will do, you will revise your notes properly. Okay, and we will have a test of 20 minutes in 20 minutes in the next class. 20 minutes in the next class we will have a test from this chapter, refraction of light. Okay, and after the 20 minutes we will start the human eye and the colorful world.
Okay. I have done.
Okay, good. So those who have completed and means first listen, again I am telling, we will have a test of simple test we will have in the next class, and of 20 minutes. Okay, and the question will be from the refraction of light only, and revise your notes properly, and this test is for your benefits only, not for my benefit, because I know all these things. But you have to give the exam, and in exam the more practice you will do, more number of question you will solve, and more you will do the revision, you will get the good marks. It's of your benefits. Okay, so those who have completed this can leave the meeting, and we will meet in the next class. Okay, and please, all of you, don't miss the next class or any class. Okay.
Okay, sir. Thank you.
Thank you,
Okay,
sir.
thank you. Thank you.
Thank you, sir.
Okay, thank you. Abdullah, written? Beta, are you in the class or not?
Yes, sir. I'm in the class, sir.
Written. So very
Yes.
good. So have you written this?
Yes, sir.
So what I have told you just now?